Hi, and thanks for watching another instructional video for CSCI 1300. In this video, we will cover user-defined input and the use of input validation to make sure that we pass edge cases when dealing with input from the user. An important application for the if statement is input validation. Whenever your program accepts user input, you need to make sure that the user-supplied values are valid before you use them in your computations. In the elevator program that we are going to be using in this video, assume that the elevator panel has buttons labeled 1 through 20, but not 13. So the following would be illegal inputs to our program: the number 13 for the 13th floor, a 0 or a negative number, or a number larger than 20, which would be outside of the range of the building floors, or additionally an input that is not a sequence of digits, such as the letter representation or the string representation of a floor, such as the word 5 compared to its actual numerical value of 5. In each of these cases, we will want to give an error message and exit the program. A simple way to check for this would be to check first for whether we're getting a numerical value or a non-numerical value. This can be done with the cin.fail function. cin.fail is being used on the cin operation, so we're checking to see if there is a true or false Boolean equivalent when this is evaluated. Since the floor is a variable that is an integer data type, we're expecting a numerical value to be stored through the cin command on line 8. So, for instance, if the user of the program, when prompted for the floor, enters a string input value for the floor instead of a numerical input for the value of the floor, then on line 13, the cin.fail check within the if statement would evaluate to true, because cin would have failed to actually store anything into the variable floor. Floor would remain empty with its previous value, and the operation would not have succeeded. So if cin fails, we can check for it, and we can print a message specifically saying that that is not an integer, that is a string. Likewise, if we do get a numerical value, but the numerical value is not what we are looking for, we can also specifically check for out-of-bounds cases. All of these would be considered edge cases for user-defined input. On line 18, we use an if statement after the first cin.fail if statement to check to see if the numerical value passes our check, and if we get past the first if statement, we know we do have some numerical value. So the next thing we need to check for is the value 13, which is one of the things that we do not want. So if floor contains the value of 13 from the user, then we will print an error message saying that that is an invalid input. And likewise, we can also set a range so that we can exclude values outside of the number of floors that are available to travel to. In this case, we're setting an if statement on line 23 that reads if the value, the numerical value in floor, is less than or equal to 0, meaning that it is 0 or a negative number, or the numerical value in floor is larger than 20, meaning that it has exceeded the number of floors available to travel to, then we will have to print an error message to the user and prompt them to try and re-enter their information again. If all of these if statements are passed over and are not true, then we will actually get to a place where we can evaluate and provide some output to the user. Another way to consider this is that we could actually look for opposite values here. So, for instance, we could structure this so that we could use a reverse logic type of thing. So we could say if cin does not fail, and then we could actually put our numerical computations within that if statement as a nested series of statements. So once we actually get to the place where we're actually getting correct input and it is past all of our edge cases, we know that we can check to see if it is larger than 13 or less than 13, and print information back to the user about which floor they will travel to. Let's run the code in the terminal and see what happens. We tried inputting information from the user. Let's try entering the word 5 to test our cin.fail. So we're testing with a string value rather than a numerical value. And we can see here that we get an error message saying that it is not an integer. So we have failed the first if check, meaning that we did not provide a numerical piece of information. On our next test, let's try the value of 13. Here, we're getting the correct message saying that there is no 13th floor, which is coming from the if statement that checks for that specific condition. Notice that our first if statement did not evaluate true, so it was skipped over. And then we evaluate the next one, and this if statement is true because we entered a value of 13, so we printed this message as a result of that and stopped our program. Let's try again, and this time try out of bounds ranges. So say we enter a number like -5, you can see that we're out of the range on the negative end of our floor spectrum. And if we try another floor that maybe exceeds the number of floors that are available, we will also be excluded in this if statement. So either of these are out, the negative number or the number larger than 20, both are excluded and pass a value of true into our if statement because our Boolean check here evaluated true. That means that we went into this if statement, we printed our error message, and stopped our program. Now, if we were to do the same thing as before, but this time enter a valid floor, such as the floor 5, you can see that we have passed over every single if check in our edge cases, and we get down to the bottom here of the code where it checks to see if the floor value is larger or smaller than 13. In this example, we skipped over our if check here because the floor value was less than 13, and this evaluated to false. So the next thing that happened was we went into an else statement where our actual floor integer was set to the information given by the user. Now, if we try the same evaluation but with something such as 14, notice that the print that we get is actually coming from this if statement where floor was 14, so it is larger than 13. So the actual floor that we have traveled to is one less than the input. This is interesting because it is technically true even though there is no 13th floor. We went to the 14th floor listed, but since there was no 13th floor, we have actually traveled up 13 floors in the building, despite the 13th floor not being actually listed as one of our options. That covers how to do input validation when using user-defined input. Thanks for watching, and happy coding!